5 minutes till other joins. I'll share one small video. This is CNC milling machine, and this is something like impeller. This is what is called as the rotary table. This is your component. This is a cutter. That is end mill, a long cutter. This is your and this is a rotary table. You have altogether 5 axes. This particular machine is called as the CNC vertical milling machine. This is also CNC vertical milling machine. This is an automatic tool changer. This automatic tool changer which is changing the tool automatically. This is again a cutter, the cylinder head. This is a coolant pipe. This particular operation is interpolation. This is one axis, and again we have one more axis here, that is this rotation. So altogether we have 5 axes can be seen here. See, this particular assembly is rotating about this axis as well as around this axis also. Component is rotating about this axis as well as about this axis. So these are the two additional axes other than X, Y, and Z. So it's a 5 axis machining. This we have seen yesterday. GMT. GMT is again this we have seen yesterday, isn't it? So I'll stop this. These are your Y's. This is your end mill. This is your workpiece. Axis which is parallel to the spindle is called as the Z axis. This is what is your end mill cutter is. End mill. 4 flute. 4 flute means it has 4 teeth. This is also called as the spindle, and this is what is your wheel is. These are the cutters. This is for the draw bolt. This is draw bolt. This is used to hold the cutter. You have to, yeah, pull the cutter from the down, and that draw bolt has a thread that goes inside, and you can tighten. This is a drill chuck. So manually you can remove this. Either it's a hydraulic clamping or it's a pneumatic clamping. It's pressing this. There are interlocks. Unless and until this is fixed, the spindle will not run. We have forward reverse arrangement, that is spindle clockwise and anti-clockwise rotation. Usually the supply is three-phase. Reversal is instant. You can see without any time lag. Without that means when the braking is also powerful. Immediately it stops. Moment to press the lever starts. Speed up of the how fast it brakes. This is for removing the cutter. That is a special spanner. This is pulley for changing the belts. That is for changing the speed. This is the auto travel of the spindle. One more small video I will show again by GMT. These are the various tools. Have a look, try to identify. This is drill, this is also drill, this is end mill, this is tip tool. Look at the kind of the
Hello,
tool.
sir. Hello. Hello, sir. Hello.
So again, this is drill, this is also a drill, this is end mill, this has two flute.
Hello,
This is
sir.
again a drill, spotted drill. These are drill chucks. These
Hello,
are
sir.
collet chucks. There is a collet inside this. This is a collet. There is a collet inside this. These are paste mill cutter. The drill chuck. All are drill chuck. This is how you have to clamp the cutter, that is, this is called as a collet, having slits. The collet is hold inside, and then this is placed on this adapter.
Hello, sir.
You have to always use gloves
Hello. Hello,
around the
hello,
cutter
sir.
placed. This is a special spanner. The special spanner is used for clamping, and this is a kind of a fixture. This is a kind of a fixture which is used for clamping, and this device is offline. Offline means your machining is going on the machine, and you are setting up another tool for the next operation. This is your coated tool, completely carbide coated tool. The lower body is high speed steel, and the coating of carbide is done on high speed steel. This particular machine is called the turn mill. Why it is called a turn mill? Because it can do turning as well as milling. These are the milling chucks. See, this is called the fixture. Fixture is used for holding the workpiece. Now here our workpiece is tool adapter. The tool adapter goes inside the spindle. This operation is called as the slot milling. This operation is called as the slot milling. This is what is the slot is. This is a drill. These are the bellows. Keyless. It is called the keyless. Keyless drill chuck. That is, you are not using any chuck key. So just, and this is just with the help of the hand pressure, and then finally this special spanner is used. See, this is how your chip should come out. That means it's a good cutting. This is called as a peck drilling. Peck. You know, woodpecker, a kind of a bird. That was a countersunking operation. See, this is a special kind of Allen key. T Allen key. Hello, hello. Yeah, 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 yeah. Yeah, I admit it. I was sure. Yeah. Hi, Shubham. Uh, hello. I admit it. Hello, I admit it. I was showing the videos. I admit it. So we'll start. I just showed three videos. Those who have missed, I will show it again in the next class. Those videos were on the milling machine and on the tooling. Yeah, yeah, Rutuja. I'm audible, no? And the screen is also visible. Hello, hello.
Yes, sir.
Yeah. Okay. So the purpose of milling machine, it is used to produce one or more machined surfaces accurately on the workpiece. What we are discussing is milling machine. This is again important examination point of view as well as professional point of view also, because lathe machine, drilling machine, milling machine you will see everywhere. So you hear the cutter is rotating, workpiece is stationary. Stationary means workpiece is not rotating. Workpiece is held on the work table, and that table can be moved or table can be fixed. So here there are two configurations. We have fixed bed type machine or you have moving bed type of machine. So in fixed bed type machine, the workpiece is not moving, which is used for heavy workpieces like big dies and big molds. And in moving bed type machines, the workpiece is not heavy or it is light, generally up to 200 kg. In case of fixed bed, your tool is moving in X, Y as well as Z direction. Most of the peoples, tool room peoples, they prefer fixed bed type machines so that even the heavy workpieces also can be milled, can be machined. If you talk about see bags made, VIP bags, suitcases, big suitcases, what we use when you go for traveling in your automobile molds. There the cavity, the weight of the cavity is 1 ton, 2 tons. So that type of components goes on the fixed bed type machines. Fixed bed means bed is not moving. So vertical milling machine is most common. This we are saying. So what are the uses of vertical milling machine? How angular surfaces can be machined? This is what we are going to see. These are the some kind of a questions which should be asked, can be asked on the milling machine. Milling machine can be used on milling, drilling, boring, and reaming operations. Mostly vertical and horizontal type of milling machines are available, and universal milling machine can do vertical as well as horizontal milling. Milling process can be angular or can be helical also. You can perform variety of operations. I'm going slowly in order to match the lag. You can perform, yesterday I showed you chamfer milling, you can perform V milling, you can perform slitting. So these are the different operations which can be done milling machine. Face milling, end milling, keyway cutting, pivoted cutting. All these videos I showed except jig boring. Jig boring is a kind of a operation where the holes are bored to an accuracy of 10 microns or 20 microns. Then fly cutter I have not shown you video. The fly cutter is the single point tool which can be mounted on the boring bar and which is used for casing operation as well as for boring operation. You are now aware how does the milling machine look like. This is a ram type of vertical milling machine, a lighter machine. This is what is ram. Now this ram can be moved in and out. So that becomes your y-axis. This is what is your fuel travel. Then your table moves up and down. That is your z axis. And this is longitudinal. That is x-axis. X-axis. This is a column. This is a ram. This is for changing the feed. Here you can see the spindle speeds. This is your feed hand wheel. This is cross feed hand wheel like this. You can move this table in and out as well as you can move this ram also in and out, right? So if the workpieces are lighter but bigger in size, then you can move this ram. You have to of course take care of the overhang. Overhang should not be much. Position it, lock it, and then further movements can be given to the table. So that was the ram type vertical milling, which is common in tool room. So the base is made up of cast iron because it has good damping characteristics. Then column is also made up of cast iron. Is again cast with the base. We don't go for MS. We don't go for welding. We go for casting only because casting has good damping characteristics. It can take vibrations. And the machining operation is chatter free. And there is another part for the overarm. When you have head, overarm means that ram. Head is attached to the end of the ram in which we fix up the spindle and the motor is on the top of the head. Cutting speed, feed and depth of cut, you are aware, already spoken when we had discussed, when we had done numerical on machining time. Again, we will have 5 marks, numerical. Cutting speed formula is V is equal to pi d n upon 1000. Then feed, here in case of milling machine, feed is expressed in millimeter per revolution or millimeter per revolution per teeth or millimeter per minute. You know that now. What are the different factors which affects the efficiency of a milling machine? So cutting speed, feed and depth of cut. These are the three factors which affects the efficiency of the milling operations. If the cutting speed is too slow, then machining time will increase. If it is fast, then cutter will blunt very fast. You will have to regrind very often. Then feed, if it is too slow, then again it will take machining time will increase. If it is fast, then again cutter teeth will break or become blunt very easily. Then depth of cut. Again, if you are taking small depth of cut, then machining time will increase. And again, if you take more depth of cut, then cutter will burn very fast. Cutting speed, as you know, it is given by the formula V is equal to pi dn upon 1000. Cutting speed is expressed in feet per minute, surface feet per minute, but in metric we express it in meters per minute. Speed is revolutions per minute, that is RPM. In case of lathe machine, workpiece is rotating. In case of milling machine, your cutter is rotating. Again and again, I am telling so that you remember it. But that is a typical question which is asked. So, cutting speed. How to determine the cutting speed? Cutting speed is based on the tool material and the workpiece workpiece material. So, it depends upon the work material, cutter material, diameter of the cutter, then surface finish, depth of the cut, and rigidity of the machine and work setup. If the work material is soft, then cutting speed can be higher. The cutter material is high tech, like carbide or ceramic or CBN. Then again, you can use higher cutting speeds. Then V is equal to pi d n upon 1000. So V, cutting speed, is a function of diameter of the cutter. Then surface finish. If you want good surface finish, then cutting speed should be high. This you have to remember. And if you use lower cutting speeds, then surface you do not get good surface finish. Again, depth of cut. Small depth of cut will give you excellent surface finish. And of course, if the machine is rigid, if there are no vibrations, or workpiece is also clamped strongly, there are no vibrations, then definitely you will get a good surface finish. Else, you will get a chatter marks. You will see chatter marks. These are the different cutting speeds, but you have to remember this only, meters per minute. And as I told, you there are so many cutting speeds which you cannot remember. So you just remember if it is high speed steel, if the cutter is high speed steel and if the workpiece meter is MS, then you use 25 meters per minute. 25 meters per minute for numerical purpose. Inch calculation is not required. So if you want a longer cutter life, then use lower cutting speed. CS means cutting speed. You must know the hardness of the material, that is workpiece which you are going to machine. If the material is hard, again you have to use lower cutting speeds. Try to reduce the feed. Instead of feed means the traverse or the travel of the tool. If you use coolant, that generally results into good surface finish, and the cutter life is also increased. So feed rate is expressed in millimeter per revolution per tooth, or millimeter per revolution, or millimeter per minute. So you have to multiply by number of teeth in order to and number and RPM in order to get feed rate in millimeter per minute. Again, the feed rate will also depend upon the various factors, that is workpiece material, tool material, then type of finish, and measuring time. If the material is hard, again you have to go slow. The material is soft, then you can go fast. So these are the factors in feed rate. If you wish, you can write it down, but simple. If the cutter is sharp, then you can increase the feed. If the workpiece material is hard, then obviously you have to go for lower or lower feed rates. Again, there are many feed rates, but you just remember what I have told. That is 0.2 millimeter per revolution if it is MS and HS combination. You know how to calculate the feed rate in millimeter per minute. Here it is inches per minute. That is n into, that is number of teeth, into feed rate per teeth into revolutions per minute. Inch calculation in syllabus, and question will not be asked also on inch, based on the inch. It will be all metric calculations. This is important from your examination point of view. What is conventional milling or what is climb milling? So you please remember another word for conventional. If you wish, you draw this, important. Conventional milling is also called as the climb milling. So here the cutter is rotating clockwise, and look at the direction of the feed rate. It is opposite to the direction of the rotation of the cutter. You observe carefully. Another observation, that where the teeth of the cutter engages the workpiece, the thickness of the chip is small, and then it goes on increasing at the end. So chip thickness is minimum at the engagement of the teeth and it is maximum at the end. This is for the down milling. Cutter is rotating clockwise and look at the direction of the piece. Here, milling cutter is trying to press the component. And chip thickness is more in the beginning and less or minimum at the end. Feed direction is in the direction of rotation. Usually question asked is differentiate between climb milling and up milling and down milling. The previous was up milling, this is down milling. So feed direction, then chip thickness, that is the second point. Then third point will be here in down milling, the cutter will try to press the component, whereas in case of up milling, the cutter will try to lift the component or lift the workpiece, lift the work. In case of down milling, the clamping of the workpiece need not be so strong because cutter helps in clamping the workpiece. Hope you understand this. Whereas in case of up milling, that is previous slide, since the cutter tries to lift the component, the clamping of the workpiece should be strong. Whereas here, the cutter will try to press the component, so the clamping, of course, there has to be clamping, but not necessarily should be as strong as up milling. I hope you are noting it. So, what are the advantages of climb milling? You get good tool life. Climb milling is nothing but down milling. Less costly fixtures required. Less costly fixtures required. Why? Because, as I told, the cutter forces workpiece down. So, simpler holding devices. You get a good surface finish in climb milling. See, remember, climb milling is nothing but down milling. There are few more advantages of climb milling. Chip removal is easy. Power requirements are less. then less edge breakouts, because thickness of the chip, it gets smaller and smaller. That's why the cutter edge will not break. Then you have disadvantages of climb milling. Remember, climb milling is also called as the down milling. It tries to pull the table. So that's why machine should have zero backlash. Means there should not be play between screw and nut. Then this cannot be used for measuring castings or hot roll steel, because in castings or hot roll steel, the outermost layer of the workpiece is hard. That damages the cutter, because even if we say that no backlash, there will be some amount of backlash in any machine. So if it is hard, if it is hard, then it will pull the cutter. So the cutter will dig in, the cutter will dig in, and accident may happen. Let's go for hand mills. So I have told you what is climb milling. Climb milling is also called the down milling. I also told you what is up milling. Generally, we use up milling. Why? Because up milling means there is no chances of accident, no pulling out. Whereas climb milling, even though it has many advantages, because of pulling of the table, accidents may happen. That's why climb milling or down milling is not preferred. Whereas in our workshop practices, we use up milling. These are the objectives, or these are the questions which can be used. That is, name the two types of material of which end mills are made and state their application. So, high speed steel and carbide. Purpose of two flute and multiple flute. So, two flute means having two teeth. Multiple flute means three, four, five. Generally, it is two or four. Then, what is the purpose of climb and conventional milling? So, these are the questions which can be asked. Since you have seen the photographs, you have seen in the videos, how does the end mill look like? Generally, it is made up of high speed steel. How do you take the cutter decision? It is based on the shape of the workpiece material, wear resistance level, hardness of the material, and the machine condition. There are many factors which determines the selection of the cutter. High speed end mills mean usually we use carbide end mills, and high speed steels, the cutting speed is 25 meters per minute, whereas a carbide coated you can use 150 meters per minute. The next is your ceramics or CBN or diamond. So there you can use still higher cutting speeds. So you can go as high as 500 meters per minute cutting speed. I'm talking about cutting speed. I'm not talking about RPM. Generally, high-speed end mills are used on CNC machines because you need higher revolutions, 5,000, 6,000 RPM, 7,000, or as high as 10,000 RPM. Your spindle should rotate at such a higher speeds. So carbide end mills, you can get higher speeds. Ceramic, you can get higher speeds. Diamonds and CBN, you can get higher speeds. Generally, on CNC machine, we use carbide end mills because our investment is high, so we should get returns fast. So if you are using carbide end mills, then you can run the machine at higher speeds and speeds. Your machining time will be less and returns will be faster. These are operations can be done on the milling machine. Some of the operations you are familiar. This is just a step milling. This is contour milling. This is short milling. This is face milling. This and this is same. This is slot milling, but this is open type slot milling, and this is closed type. This is also for the pocket. Again, this is the open type of pocket. You can have closed type of pocket also. For the different forms of the end mills. So you have flat bottom end mill, like the bottom of the end mill is flat. An end mill can have full radius, not radium. No, please correct this. Not with full radium, full radius. That is, end mill bottom will have a radius. Then end mill with corner radius. End mill with corner radius means only the corners. End mill for corners has radius, not radium. So these radius wala end mills are called as the ball nose. If it is full radius, like this, then it is called as the ball nose. And if only the corner has radius, then it is called the bull nose. There is no spelling mistake here. Please remember. This is ball and this is bull. This radium, there is a spelling mistake. It should be read as radius. See, this is what is your ball nose end mill. And this is your bull nose. Bull nose end mill. So bull nose end mill has corner radius. Ball nose radius has complete radius. Just a minute, hold on. Trying to see how much I can cover up today. Okay, we'll try to cover as much as possible, but definitely there is no need to hurry because what is important or what I believe, understanding is important. You must understand. You can stop me at any time and ask the question. No need to have any fear or should not feel shy. asking the questions. I understand you're just second year students, so you may be feeling shy. That's why you may not be opening out. But everybody is like that. Those who have background, those who are entrepreneurs, since they are working, they are assisting their family business, they know the things. But the course is designed for, it's an average course. It doesn't demand too much of intelligence. So type of the endmills, one is ball nose, then another is bull nose. Then you have three flute endmill. That means if you have three flutes, you have roughing endmills also. Roughing endmills, if you remember yesterday, I showed you in the video that staggering type of endmill cutter. So that is what is your roughing endmill. Then climb milling is down milling that we discussed already. Conventional is called as the up milling. That is cutter rotation and table feed rate, they are moving in opposite direction. See, look at this now. Here the cutter rotation and the feed is opposite, so this is called the conventional milling, or it is also called as the up milling. Look at this now, cutter is rotating like this and the feed is also in same direction, so this is your climb milling, or it is called the down milling. Here the chip thickness is more at the beginning and less at the end. Here it is ulta. The G41, G42, these are the ports that are given on the CNC machines. Don't bother much about the port now. Cutter can fail because of the heat, so that's why you have to use coolant, and because of the abrasive, that's why you have to dispose of the chips. Otherwise, because of the abrasion also, the cutter will get damaged. Chipping or crumbling of cutting edges. That is because of the hard spots. Because of the hard spots, the cutting edge will get damaged or small fracture will occur. So you have to take care of the friction, you have to take care of the heat, you have to have proper horsepower requirements. Then clogging, that is chips should be disposed of properly. So your coolant force and the coolant direction should be proper so that your chips are disposed of properly. Chips are not clogged, right? Right. Clogging is also due to gummy kind of workpiece material. Gummy. Gummy means like rubbery kind of actions. So because of that, your chips get clogged inside the cutter, and then the cutter is damaged. Then because of the heat and because of the cooling, see here, there's a, because of the friction and because of the cutting forces, the workpiece gets hardened. You know, so that is what is called the work hardening of the workpiece. And then this hardening, even that is, you'll wonder that array, the workpiece so soft now, so how it has hardened. So that is nothing but some heat treatment process is happening during machining. Why heat treatment process is happening? Because the workpiece is getting heated and then it also gets cooled down, the coolant. So that heating and cooling will cause metallurgical changes inside the workpiece, and that is what is will result into the hardening of the workpiece, which is called the work hardening, and this will damage the cutter. So that care again has to be taken. Right. Then, what are the operations which can be done on the vertical milling machine? So vertical milling machine, I have shown you how does it look like. You know, the this is the most common machine, vertical milling machine. is preferred over horizontal because it is easy to operate and most of the operations can be done on the vertical milling machines. Generally, over horizontal milling, we prefer vertical milling. Most of the workshops they have universal milling machine. Means universal milling machine means can have horizontal milling as well as vertical milling on the same machine. Aligning the vertical head means your head in case of vertical machine should be perpendicular to the table. The spindle should be perpendicular to the table. Head must be square to the table, that is 90 degrees. That is what is called as the aligning. So that's why we generally avoid tilting of the head because once the head is tilted, then again it has to be brought it back. Again it has to be aligned. So aligning is not an easy task. You have to have a test mandrel. You have to put the test mandrel inside the spindle and you have to use a dial indicator to check whether it is aligned properly or not. So that setting takes time. So that's why generally we don't tilt the heads. Don't tilt the heads. This is again a procedure which is explained. Is you have to loosen the head, then you have to put a test mandrel, then you have to put a dial indicator. So this is not required from examination point of view. Then you have to align the vice. Yeah, vice alignment is important because you are holding your workpiece in the vice. So the alignment of the vice is very important. So the vice should be perfectly parallel as well as there should not be any chips below the vice. So whenever you're mounting or clamping the vice on the table, you need to align the vice in both the directions, that is in x direction as well as in y direction properly. Wallets, as you know, it is used for holding the tools. Wallet you are seen as the slits inside. So suppose if the wallet size is say 25, then that 25 collet, suppose if the wallet size is 25, then 25 collet will hold the cutter diameter from 24 to 25. So wallets are made up of spring steel, that is EN47. It has slits here. So because of the slits, it can expand and collapse. And that variation of 1 can be taken. Remember, wallet holds on the entire circumference, so the grip is good, and cutter also doesn't move out. So it moves concentric. Concentric means it moves true with respect to the spindle. So if the spindle is rotating within say 1 micron, your collet will also rotate, and hence the cutter will also rotate in 1 micron. So this is a typical collet, spring collet made up of EN47. You can have solid collet. This is also called as the side lock cutters. Side lock cutters means this is a screw, and you have to insert your cutter inside this bore. Your cutter will have a slight flat. So on that flat, you have to clamp this screw. So in addition to grip on the circumference, we are also clamping on the flat. So this gives a good grip for the cutter. If the cutter has good grip, then your cutting efficiency will increase. This is how the quality is fixed to the machine with the help of the drawbar and the collet. So to fix up this drawbar from the top, then you have to insert this collet and then tighten. Okay, you have another lecture. We will stop here. If you have any doubts, you can quickly ask. And quickly take up the questions. Yeah, Ritika, any questions? I'll upload this Google Classroom. Fine. Then, if you wish, you can leave. Thank you so much. Okay, now I am also leaving.